No study of gravitation would be complete without an examination of Kepler's 3 laws. The first law says that the orbit of a planet is an ellipse with the sun at one of the foci. And in my diagram, you can see we've got an ellipse. It's a elliptical, right? With the 2 foci, there's the sun, and the little blue dot above the sun is the planet orbiting it. That ellipse represents the planet's orbit. Kepler's second law is equal swept areas, and it says that any line joining a planet and the sun sweeps out equal areas during equal time intervals. So in my diagram below, we have 2 areas, and they're equal, and that means that the time it takes a planet to go from one side of the area on one little shape to the other is the same time. So that means when the planet is closest to the sun, it's going faster. Kepler's third law says the square of the orbital period is directly proportional to the cube of the semi-major axis of its orbit. On the left bottom, we have the semi-major axis. It's half the longest axis. On the right, we have the equation where the period equals 2 pi, a to the 3 halves, where a is the semi-major axis, over the square root of g, the constant 6.7 times 10 to the negative 11th newtons meter squared over kilogram squared, times the mass of the sun.